Hi, in this video, we will talk about the substitution rule, which is one of the technique of integration. There are two parts for this package. The first one, we will see the indefinite integrals, and the second part will be the definite integrals. Let's get started. This process is used to find the antiderivative as the way that we think of the backward chain rule. First of all, look at the procedures. In step number one, from the given indefinite integral, we will see the involving composite function as part of the integrand. We have to identify the inner function and let it be the new variable u. That is why it's called the u sub technique. Let u be the function g of x. And then we should see in some form of the multiple of the function u, and the u prime or g and the g prime appears in the integrand. Next, we will substitute u equals g of x and the differential u in the integral. Next, we will evaluate the new indefinite integral with respect to u. Lastly, we will write the result in terms of x using u equals g of x, and then we are done. See the first example. We will evaluate the following indefinite integrals, and we can check the answer by doing the differentiation. This part A, we see the integrand in the form of the 2x multiplied by the radical x squared plus 1. We see the square root of x squared plus 1 as a composite form. In this case, the inner function is x squared plus 1, so we let u be x squared plus 1. The differential u, which let's start with the derivative. du by dx is 2x. That will give you the differential u in the form of 2x multiplied by dx. Back to the problem. We can replace the u and du into the integrand. We'll see the radical x squared plus 1 will be replaced by square root u. And then the 2x times dx is the same form of du. 2x dx here is du. And then we'll see the integral is in completely form of the u and the du. Next, we just apply the appropriate antiderivative rule. We change the square root u in form of u to the power 1/2. The result will be u to the power 1/2 plus 1 divided by 1/2 plus 1 added by c, which is the constant of integration. Simplify the algebra. We will get u to the power 3/2 divided by 3/2, which is the same as multiplying by 2/3 plus c. And the last step, we replace the u with the term of the function x, which is x squared plus 1 to the power 3/2 plus c. So that is your answer. We could check the result by finding the derivative. So the derivative of 2/3 times quantity x squared plus 1 to the power 3/2 plus c will give you 2/3 with the, so now we apply the chain rule. 3/2 x squared plus 1 to the power 1/2, and then multiply by the derivative of the inner function, which is 2x. Derivative of c is 0. Simplify as much as we can. So 2/3 and 3/2 reduce. It becomes 2x power 1/2. That is the same as square root x squared plus 1. And then you can see it returns the same form as the integrand.